Okay, so in this video we are introducing what is called Pearson's correlation coefficient. And before we go into this, I just want to bring your attention back to something we discussed in the previous video, which is when we talked about the strength of an association as a means of measuring how much scatter there is in a scatter plot. Now, I introduced these three in the previous video. We looked at a strong, moderate, and weak association. Now, before introducing this correlation coefficient, when we look at these types of associations, we really just have to sort of eyeball it and make a rough educator guess on the strength of the association. We look at something like this one on the left and we say, okay, the points look really packed in, they're really resembling something linear, we're going to say it's strong. When we look at this one, we say, well, it's definitely not as strong as the one before. It's a little bit more spread out. Let's call it moderate. And this one here is weak. Everything looks quite scattered here. What Pearson's correlation coefficient gives us is this is a mathematical way of coming up with a number based on our bivariate data to tell us how strong our data is. Now, if you look at this dot point down here, our Pearson's correlation coefficient, we often call this R, we give this the letter R, it measures the strength of linear association and ranges from -1 to 1. So this is a range of values from -1 to 1, in which -1 is going to be a strong negative association. And a hint here is this negative sign in front. This is going to be a negative in the negative direction. And our positive one here is going to be our strong positive. Now, everything in between these values, this range from -1 to +1, is going to determine, we have some little key numbers that are going to tell us whether this is strong, moderate, weak, or no linear association whatsoever. Now, I can't show you how to generate this on your calculator because I don't have an emulator. Maybe that'll come up in a later video. We're just really discussing the concept here. But the associations can be categorized based on the Pearson's correlation coefficient. So I'm going to draw up a little table in this video. So I'm going to have my association on the left-hand side and my R, my Pearson's correlation coefficient, on the other one. So in order to get a strong positive, my R value, once we put it into our calculator and find it, or if we're given it in a question, the R is going to range from 0.75, so R is going to be greater than 0.75 and less than 0.99. Now, the reason we're going up to 0.99 is that 1 is really, really rare. We have to have these points sitting essentially perfectly on a line, which often never happens with bivariate data. Now, we have a strong positive. Our next one down is our moderate positive. And this is going to go from 0.5 to 0.74. Our weak positive goes from 0.25, and it goes without saying, but all of these values I'm writing down on the right-hand side are positive. This will become clear later on. But this is our range for weak negative and no linear association. That is going to be from -0.24 to positive 0.24. Now, what that means is that when we get into the negative associations, because remember we can have a positive or negative, all these values are really close to 0. 0 is basically going to just be a complete scatter with no association correlation whatsoever. That was that example I did at the end of last video where I had these dots all the way all over the place. There's no rhyme or reason to them. This would have an R value of 0, for example. Now, as our association gets really weak in between these ranges of R values that I've written here, between negative 0.24 and positive 0.24, we're going to categorize all of that as no linear association. And the same thing kind of happens when we look at negative numbers. I won't write all of them, but our weak negative is going to be between negative 0.25 and 0.49, and the others are just going to continue that, mirroring these ones up here, but just in the negative direction again. Because remember, we can get a strong association, but in the negative direction as well. Strength and direction of association are two different things. So you can have strong, moderate, and weak ones in the negative direction also. But this allows us to classify the strength of association. So once we have a set of data values, we put them into our calculator, we can categorize them and answer questions that when we get our R value back, this is a really quick way, instead of drawing the scatter plot and eyeballing it, we can quickly input this into our calculator and then make a judgment on whether this is going to be strong positive, moderate positive, weak positive, no linear association, or something in the negatives as well. And Pearson's correlation coefficient, as we said, it measures the strength of linear association. So we no longer have to eyeball these like we did on our graphs here. We can even start to estimate here what our correlation coefficient is going to look like roughly. So for a strong one, this is a strong positive, our R value is going to be approximately positive 0.9. Our moderate one, this looks like approximately positive 0.5. And our weak one is going to be about positive 0.3. So obviously we have a range here, and I've just estimated these values. But as you start writing these in your calculator, actually using the technology to find this Pearson's correlation coefficient easily, you will be able to determine the strength of any scatter plots and their linear associations that you come across. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.